In IT, new tools and trends come and go, but at the core of every system is the database, quietly powering every app, service, and decision. Data drives business. How we store and access it shapes our success. Staying relevant means mastering the basics. The database is the backbone of every digital system. The wrong database slows teams and risks your business. The right one enables growth and innovation. Everyone, developers, architects, product managers, needs to understand databases. Collaboration is key. When things break, real database knowledge matters. It's what turns quick fixes into lasting solutions. In this video, we'll show how databases have evolved and why they're still the foundation of IT relevance. Let's dive in. The history of databases is a fascinating reflection of how computing itself has evolved over the decades, adapting to new challenges and opportunities. Back in the 1960s, databases were built on hierarchical models. Imagine data organized like a family tree, efficient for certain tasks but extremely rigid and difficult to adapt. If you needed to ask questions outside the original design, it often meant expensive and time-consuming redesigns, making innovation slow and costly. The 1970s marked a turning point with Edgar F. Codd's revolutionary relational model. Data was now stored in tables, linked by shared values, and could be queried flexibly using SQL. This new abstraction separated the way data was logically organized from how it was physically stored, dramatically boosting both productivity and flexibility for businesses and developers alike. Relational databases like Oracle, IBM DB2, and later MySQL and PostgreSQL became the backbone of enterprise computing, dominating the industry for decades and powering everything from banking to e-commerce. In the 1980s and 90s, object-oriented databases emerged, aiming to bridge the gap between programming languages and data storage, but they struggled to gain widespread adoption. The explosion of the internet in the 2000s changed everything. Suddenly, companies like Google and Facebook needed to store and process data at a scale never seen before, far beyond what traditional databases could handle. Enter NoSQL, a new family of databases, including document, key value, and column family stores, designed to handle massive volumes of unstructured data and deliver high performance at scale. Graph databases also emerged, making it easier to model and analyze complex relationships, such as social networks or recommendation engines. NoSQL databases often traded strict consistency for greater scalability and availability, enabling global applications to serve millions of users in real time. The era of one-size-fits-all databases was over, replaced by a landscape where specialized solutions could thrive. Today, we have a rich and diverse ecosystem, with each database type tailored to different workloads, industries, and use cases. Understanding this ongoing evolution helps us make smarter technology choices. The journey of databases is far from over. Innovation continues to shape the future. Database evolution is driven by three forces: governance, cost, and convenience. Governance means rules, security, and compliance. Think GDPR and HIPAA. Early databases were centralized for control and integrity. Cost has always mattered. Open-source databases like MySQL democratized access, while NoSQL enabled scaling with cheap hardware. Convenience is about developer experience. SQL made querying easy, and now cloud services let you spin up databases in minutes. These forces are always in tension. Maximizing convenience can weaken governance. Strict governance can raise costs. The cheapest solution might lack critical features. Our job is to balance these trade-offs: speed, cost, and control. The best choice is rarely at the extremes. Instead, it's a thoughtful compromise. Understanding these pillars helps us pick the right tool for the job. Despite new tech, relational databases remain the backbone of data management. Their strength, data integrity, schemas, constraints, and ACID transactions keep data reliable. SQL is powerful, stable, and universally understood. It lets you describe what you want, and the database figures out how to get it. The SQL ecosystem is vast, and SQL skills transfer across roles and systems. Modern relational databases have addressed many old criticisms, scaling better than ever. New SQL systems combine horizontal scale with strong consistency. For structured, interconnected data, relational databases are often the best starting point. Mastering SQL is a timeless investment in your tech career. NoSQL means not only SQL. It's about using the right tool for the job. The internet era brought big data's 3 V's: volume, velocity, and variety. NoSQL databases emerged: document stores for flexible data, key value stores for speed, column family stores for analytics, and graph databases for relationships. These systems often relax strict consistency for scale and availability, using BASE, basically available, soft state, eventual consistency. This trade-off isn't for every use case. Banking needs ACID, but social media can handle eventual consistency. The key is understanding when to use which model. NoSQL expands our toolkit, not replaces SQL. Choose based on your data's needs. The age of one database for everything is over. Welcome to polyglot persistence. Modern apps use multiple databases: relational for transactions, document for catalogs, key value for caching, search engines for queries. This is the modern data stack. Data ingestion, central storage, warehouse or lakehouse, transformation, and analytics. Tools like dbt transform raw data into trusted assets. BI tools like Tableau and Power BI unlock business value. Each layer is specialized, working together like a symphony. IT pros must understand how these pieces fit and how data flows end to end. Mastering just one database isn't enough. It's about orchestrating the whole stack. With so many options, database selection can be daunting. Start with your data. Is it structured, semi-structured, or unstructured? What consistency and scalability do you need? Consider future growth. How much data, how many operations, and what kind of scaling? Evaluate operational complexity and community support. Sometimes mature tech is the wiser choice. Total cost includes licensing, hiring, and maintenance. Design for flexibility. Decouple your app from the database using clean patterns. This makes future migrations less painful and gives you strategic agility. Choose the right tool for now, but keep your options open. In today's fast-changing tech landscape, staying relevant means committing to continuous learning. But it's not just about learning everything. Focus your skills by your specific role to maximize your impact and career growth. Developers, go beyond just using your ORM. Master SQL fundamentals, but also get hands-on with at least one NoSQL database. Learn the strengths and weaknesses of each, and understand real-world scenarios where one outshines the other. This versatility will set you apart. Data scientists and analysts, deep SQL skills are non-negotiable. Get comfortable with cloud data warehouses and explore tools like dbt for transformation. Don't forget to master frameworks like Spark or Pandas for working with large-scale data lakes and complex analytics. DevOps and SREs automate database provisioning and scaling, become an expert in monitoring, backup, and recovery, and dive deep into cloud DBAS performance and reliability. Your role is critical for keeping systems running smoothly. For everyone, embrace the cloud, because most new deployments are now cloud native. Understanding cloud fundamentals is essential for every tech professional. Learn the ins and outs of managed services, security best practices, and cost models for AWS, Azure, and GCP. Knowing how to choose and optimize these platforms is a must-have skill. The future is all about cloud and data working together seamlessly. Integration is the new normal. T-shaped skills, having deep expertise in one area but broad knowledge across others, make you truly invaluable in any organization. The lines between traditional roles are blurring. Today's projects demand flexibility and a willingness to step outside your comfort zone. Collaboration across the entire data stack is now key. Success comes from working together and sharing expertise. Invest in your data skills and keep learning. This is the best way to ensure your career longevity and adaptability in a changing world. The best professionals now combine deep database knowledge with cloud expertise. This powerful combination is quickly becoming the new industry standard. From rigid hierarchies to today's cloud-native world, the principles of data management endure. Integrity, availability, performance, and security are always essential. Governance, cost, and convenience shape our choices. Polyglot persistence gives us a diverse toolkit, but demands critical thinking. Don't chase trends. Choose the right database for your needs. Continuous learning is the path to relevance. The lines between roles are fading. Everyone needs data fluency. Build strategies that balance agility and stability. Give your database choices the attention they deserve. Thoughtful data management makes you an architect of robust, valuable systems.